Welcome students, welcome to the video class. Today we will discuss vector form of electric field intensity and next we will discuss the properties of electric field lines. ठीक है? So let us start the vector form of electric field intensity. In case 1, let us consider a charge placed at origin in air medium. Let us consider a point P which is r distance from the charge Q. At point P, we are going to find the electric field intensity due to the charge Q. Point P रे हमें electric field intensity बाहर करिबा due to the charge Q. ठीक है? For that, let us place a test charge. Let us place a test charge at point P. So the test charge placed at point P will experience a force due to the charge Q. So it will experience a force in outward direction. So what is the magnitude of the force experienced by the test charge? So it is equal to, that is 1 by 4 pi epsilon naught. This is Q naught divided by R square. ठीक है? तो 8 ही, this is the magnitude part. यदि vector form लिखिबा of the force, so we have to add magnitude with direction. So that is equal to 1 by 4 pi epsilon naught. This Q naught divided by R square. So this is the magnitude part. So for the direction, we will add a unit vector along the direction of R. So that is, unit vector along the direction of R is R cap. ठीक है? तो हमें जानी चाहिए that is a unit vector is equal to that vector divided by its magnitude. Yes or no? And this, the magnitude of R is equal to R. Okay? तो हमें 8 ही substitute करियो. तो 1 by 4 pi epsilon naught, this is Q naught. तो ये R जगह substitute करें, that is R vector of magnitude. So this is R vector of magnitude and square into R unit cap is that vector divided by its magnitude. तो it power 1 और 2 तो कितना हो Q. So this is equal to 1 by 4 pi epsilon naught is Q naught by R vector the magnitude of Q into R vector. So this is the value of force experienced by the test charge. So again, electric field intensity at point P is the force experienced by the test charge. Electric field intensity at point P is the force experienced by the test charge. ठीक है? So F is how much? 1 by 4 pi epsilon naught, that is Q naught divided by R vector of Q. Sorry, R vector magnitude of Q into that vector divided by Q naught. तो Q naught cancel. तो रोहिला कहते, that is, so you can say this E is equal to 1 by 4 pi epsilon naught Q divided by R vector of magnitude of Q into R vector. So this is the value of electric field intensity experienced by the test charge. So electric field intensity at point P, that is equal to 1 by 4 pi epsilon naught Q by R vector of magnitude of Q into R vector. ठीक है? So what is the direction of electric field intensity? So for a positive charge, the electric field intensity is outward. Again, this F रो direction जहाँ E रो direction same, that is outward. So the direction of electric field intensity will be outward and it is equal to 1 by 4 pi epsilon naught This is q by r vector of cube into r vector. Then we will move to case 2. In case 2, let us consider a charge q placed at point S. The point S is r distance from the origin, or you can say the charge q which is placed in AR medium at point S is having positional vector r with respect to the origin O. Let us consider another point P जोठी हमें इलेक्ट्रिक फील्ड इंटेंसिटी बाहर करिवा for the charge q placed at S. Again, point P रे हमें इलेक्ट्रिक फील्ड इंटेंसिटी बाहर करिवा for the charge q placed at S. Let the point P is r distance. Let the point P is r naught distance from the origin O. Or you can say the point P is having positional vector r naught. To find the electric field intensity at point P, let us consider a test charge, or let us put a test charge at point P. तो point P रे जो test charge Q naught अच्छी, so the test charge will be repelled by the charge Q present at point P. तो charge Q test charge को repel करियो in this direction. ठीक है? Okay. अब वो कथा कि this is this is OS. Okay. And this is OP. And this is SP. So, and this is R, and this is R naught. So we can write using vector triangle law vector addition, that is OS plus SP is equal to OP. That means SP vector is equal to OP vector minus OS vector, or that is equal to OP is R naught and OS is R. ठीक है? तो SP is equal to R naught minus R vector, and magnitude of SP कितने हो? So that is R naught minus R vector रो mod. ठीक है? Okay. Next we will write the force experienced by the test charge placed at point P. So magnitude of force कितना है? So that is 1 by 4 pi epsilon naught. This is Q naught by, that is SP the whole square. So the vector form लिखियो force रो, so this is the magnitude part, direction part would add करियो. So this is 1 by 4 pi epsilon naught. This is Q naught by SP whole square. And unit vector जो add करिवा, तो it is along the direction of SP. तो force से direction में पड़ुची, तो SP रो unit vector. So that means 1 by 4 pi epsilon naught. This is Q naught by SP रो whole square into SP unit vector is equal to that vector divided by its magnitude. So that is SP vector by SP vector रो magnitude. तो SP is equal to SP vector रो magnitude. So we can write this as 1 by 4 pi epsilon naught. This is Q naught by, it SP अच्छी, it SP square अच्छी. So both are equal. तो कहते हैं जो SP vector रो magnitude रो cube into SP vector. ठीक है? तो SP रो वैल्यू पके दो, so that is 1 by 4 pi epsilon naught, this is q naught divided by SP vector रो magnitude केतो है वो, that is r naught minus r रो q, and SP vector is equal to, that is r naught minus r. So this is the value of F, or this is the value of force experienced by the test charge, ठीक है, at point P. So again electric field at point P is equal to the force experienced by the test charge. तो कहते हैं वो, तो electric field intensity at P is equal to force experienced by the test charge, ठीक है. Force value is this much, this is 1 by 4 pi epsilon naught, this is q naught by r naught minus r vector of cube into r naught minus r vector, ठीक है, divided by, that is q naught. Okay, so q naught cancels out. So this is 1 by 4 pi epsilon naught, this is q by r naught minus r vector of cube into r naught minus r. So this is the value of, electric field intensity experienced by, electric field intensity at point P due to the charge q. What is the direction of electric field intensity? The direction of electric field intensity is same as the direction of force, that is outward. So electric field direction कौन होगा? Electric field intensity रो, that is along the direction of SP, ठीक है. Next is the properties of electric field lines, ठीक है. So we know that when we place a charge in a medium, the charge will produce electric field lines. These field lines will travel in the medium, and जो पर्यंत the field lines will travel, that is called the field of the charge. Again, जो पर्यंत the electric field lines will travel in the medium, that is called the electric field of that charge, ठीक है. तो डिफाइन करें इलेक्ट्रिक फील्ड लाइंस कौन. An electric lines of force, or that is electric field lines, is defined as the path, straight or curved. The electric field lines can be straight or curved, along which a unit positive charge is urged to move when free to do so in an electric field. In an electric field, the path followed by the unit positive charge is the path of the electric field lines. The field lines can be curved, can be straight. Again, it is the path followed by the unit positive charge if it is freely placed in the electric field, and the path can be straight or curved. Let us take an example. Let us take a positive charge. The positive charge will create electric field. So the path followed by the unit positive charge is the path of the electric field lines. तो एक positive charge रो electric field lines बाहर करियो. तो ସେଥିପାଇଁ let us take a unit positive charge. Again, the path followed by the unit positive charge is the path of the electric field lines of this charge. So these are the two positive charges. So this unit positive charge will be repelled in outward direction. So it will move in this direction. That means this is the direction of electric field lines of this charge. It will move like this way. So this is the direction of electric field lines. So from this we can say the electric field lines for this positive charge is outward in nature, straight outward undeviated. Straight outward undeviated. So the negative charge number. So let us consider negative charge. The negative charge will create electric field around itself. ଯଦି ଗୋଟେ unit positive charge ରଖିବା, again the path followed by a unit positive charge is the path of the electric field lines. ଯଦି positive charge ରଖିବା, unit positive charge, this will be attracted by this negative charge, so it will move in this direction. ଯଦି ଏଇଠି ରଖିବା, it will move in this direction. That means we can say the direction of the positive charge, unit positive charge, is the direction of electric field lines of this charge. So in this case, it is also straight in this direction. ଆମେ କହିବା totally ଯଦି କରିବା, so these are also straight in nature, but inward. The electric field lines for the negative charge is straight inward undeviated. Okay, so let us consider two charges, positive and negative. So ଯଦି suppose ଗୋଟେ unit positive charge ରଖିବା, let us this Q. So this charge repel, this charge attract. So this charge plus charge को repel करियो, minus charge को attract करियो. So it will move in this direction. So the path followed by a unit positive charge is the direction of electric field lines for the two charges. So in this case it is curved. So it will move in this direction. That means in this case the field lines are curved. In this case the field lines are curved in nature. That is the path followed by a unit positive charge. Electric lines of force is defined as the path straight or curved, straight curved, along which a unit positive charge is asked to move when free to do so in an electric field. The direction of motion of unit positive charge gives the direction of lines of force. So एठी outward थिला, तो direction of lines of force is outward. एठी inward थिला, direction is inward. एठी from positive to negative. ठीक है? Okay. First property of electric field lines. Okay, electric field lines always starts from the higher potential, ends in the lower potential. Higher potential ends in the lower potential. Or you can say electric field lines always starts from the positive charge, ends in the negative charge. Positive to negative or higher potential to lower potential. Electric lines of force starts from positive charge and ends in the negative charge. Starts from positive charge, ends in the negative charge. Electric field lines starts from the higher potential and ends in the lower potential. We can also say electric field lines starts from higher potential, ends in the lower potential. Second property. Suppose this is the field lines. Suppose A जगह मते electric field intensity रो direction find करना है. So draw a tangent at this point. It will give the direction of electric field intensity at this point. That means the tangent drawn at any point on the lines of force gives the direction of electric field intensity. Tangent at any point on the lines of force gives the direction of electric field intensity at that point. Suppose this is positive, this is negative. So A जगह electric field intensity बाहर करें. Draw a tangent, it will give the direction. A point बाहर करें, draw a tangent, it will give the direction of electric field intensity at this point. Similarly, যদি এইটি বাহার করে আছে draw a tangent, it will give the direction of electric field intensity at this point. ঠিক আছে? Third property is important. Even exams রে আছে, it's a 2 marks question. ভালসে বুঝো. Again I am saying it's a 2 marks question. This property number 3. तो ଆମେ ଜାଣିଛେ कि electric field lines always start from the higher potential ends in the lower potential, or it starts from the positive charge ends in the negative charge. That means it has only one direction, that is from positive to negative. And the tangent at any point gives the tangent at any point on the lines of force gives the direction of electric field intensity. The tangent at any point on the lines of force gives the direction of electric field intensity. So that means we can say electric field lines have only one direction, that is from positive to negative. So that's why they will never intersect with each other. These field lines will never intersect with each other. Suppose if we say they intersect, they intersect, so let us say these are the two lines of force, and let us say they intersect at this point. So at the point of intersection, first line ପାଇଁ ଗୋଟେ tangent କରିପାରିବା, second line ପାଇଁ ଗୋଟେ tangent କରିପାରିବା. So that means these two tangents give two direction of electric field lines, which is not possible. काहेकि? Because ଆମେ ଜାଣିଛେ electric field lines have only one direction, that is from positive to negative. तो जदि ଆମେ କହିବା they intersect, then at the point of intersection dita tangent आସୁଛି, dita direction ଦେଖୁଛି, electric field of dita direction, which is not possible because electric field lines have only one direction, that is from positive to negative. Two electric field lines never intersect with each other, because they have only one direction, that is from positive to negative. Because if they intersect, যদি ସେମାନେ intersect কলে, at the point of intersection two tangents can be drawn. At the point of intersection two tangents can be drawn, which will give two direction of electric field lines, which is not possible because we know electric field lines have only one direction, that is from positive to negative. The next property is the number of lines of force per unit area is proportional to the magnitude of electric field intensity. Okay, let us write the formula of electric field intensity. So E is equal to, this is 1 by 4 pi epsilon this Q by R square. So if R को constant नबा distance, so this is constant, so we can say this E is proportional to Q. So that means we can say more is the charge, more is the number of field lines produced by the charge, and more is the electric field intensity. Okay, যদি ଅଧିକା charge ଥିବ, ଅଧିକା electric field lines ଥିବ, and more is the electric field intensity. ठीक है? That means we can say more number of field lines represent stronger electric field intensity. More number of field lines represent stronger electric field intensity. Less number of field lines represent weaker electric field intensity region. The number of lines of force is proportional to, the number of lines of force per unit area is proportional to the magnitude of V. Adhika lines of force means stronger electric field intensity. Less number of field lines represents weaker electric field intensity. More concentration of field lines means stronger electric field intensity. When you take a positive or a negative charge, single positive or a single negative charge, the field lines are straight and outward, and in the case of negative, the field lines are straight and inward. ठीक है? But whenever we take two unlike charges placed near each other, the field lines they starts from the positive charge ends in the negative charge. So that means the field lines which was moving in a straight path, now it bends and moves towards the negative charge. So that means there is a contraction of field lines when two opposite charges are placed near each other. That is the property. The lines of force tends to contract longitudinally, or that is called lengthwise. Due to this property, two unlike charges attract each other. Due to this contraction, we can say two unlike charges attract each other. And when we place two like charges, the field lines they move away from each other due to this lateral pressure or due to this repulsion. Again, ଯେତେବେଳେ ଦୁଇଟା positive or negative charge ରଖିବା, the field lines tries to move away from each other, or we can say the two charges exert lateral pressure. ଯଦି ଆମେ ଦୁଇଟା positive charge ରଖିବା near to each other, the field lines move away from each other, or we can say the two charges they exert lateral pressure, and due to which the field lines move away from each other. So the lines of force tends to exert lateral pressure, that is they repel one another laterally. This explains the repulsion between two like charges. Next property. तो हमने डिस्कस करी थिले कि when we give a charge to a conductor, the charge will come to the surface of the conductor. The charge will come to the surface of the conductor. When the charge comes to the surface of the conductor, it will produce electric field outside of the conductor. Outside of the conductor. That means electric field due to a charge inside the conductor is not possible. Again, electric field due to a charge inside the conductor is not possible. Okay. And out of that, when the charge come out of the surface of the conductor, whether it is a positive or a negative charge, they come out of the surface normally, or these field lines come out of the surface perpendicularly. Positive line the field is outward and these field lines are perpendicular to the surface. Negative line the field lines are inward and these field lines are perpendicular to the surface of the conductor. The lines of force meet the surface of the spherical conductor normally. Jodi suppose semane kiछि angle kori thante. Suppose the electric field lines make some angle not 90 degree. तो जदि semane kiछि angle kori thante not 90 degree, तार दीटा component ही थांता. One is perpendicular component, another कौन ही थांता parallel component. Again, जदि these field lines are not perpendicular to the surface, तो semane kiछि angle kori thante. So let us say this electric field making some angle. तार दीटा component ही थांता, that is E cos theta and E sin theta. So this E sin theta is moving inside the conductor. This component is moving inside the conductor. This is not possible. हमें just कहले कि electric field due to a charge inside the conductor is not possible. सेटा ही लिखा है जी. If it were not so, यदि this perpendicular है न थांते, the electric field intensity will have a component that is E sin theta. parallel to the surface of the conductor. This means a flow of current which is absurd. So the electric field is making some angle with the surface of the conductor. Theta, there are theta component. One is E cos theta which is perpendicular to the surface, and E sin theta which is parallel to the surface, or it moves inside the conductor, which is not possible. Next property is electric field lines never passes through the conductor. Today I may just discuss. Okay. Ninth property is electric field lines never form closed loops. This is important. Electric field lines never form closed loops. Okay, this they never form closed loops. So let us say this is a positive charge. So positive charge by field is outward. But जेतବେଳେ ଆମେ closed loop करिबा, the field lines are moving, or the field lines is moving inside the positive charge. That is not possible, because we know electric field is outward for positive charge, negative by it is inward. So एटी कोन होची, यदि positive charge नहोचे एटी outward भी होची, inward भी होची, so it is not possible. So we can say electric field lines never form closed loops. Next is last property. One unit positive charge gives 4 pi lines of force.